So this is going to be question number 5 on the discussion, and this is maximum path sum. And so what happens here is that we have like a tree that we want to take care of. For example, it might be like 1, 5. I'm writing the 1 in the doc test right here. So 1 and the 3 right there, and like a 10 tree right there. And so what we want to do is that we want to find the maximum like path, like sum of like any path. And so in this case, there's like 151 that has like a sum of 7, 153, that has a sum of 9 or something, 110 that has a sum of 11. And we want to find the maximum sum. So we take that 11 and that's what it should return. And so so what I want you to think about is, once again, just try to think about this every time you do trees or like tree recursion, is think about what calling like the recursive call max path sum on this branch is going to return, because like we're pretty much always going to want to do that. And what happens when we call it on this 10 right here. And so if you haven't already, take a couple minutes, try to do the problem. It's pretty similar to the one that we did before. So in the case of like height of t, it's going to be like, so in the case of here, we took like the maximum height and like added 1 to it. Same idea might apply to maximum path sum. So think about it for a couple minutes, and now let's get started. Pause the video, let's get started now. So what happens here is, let's take a look at these recursive calls. So making a recursive call on this tree, so the 5, 1, 3 tree, is going to give us 8 because this path gives us the highest sum. And then on the other hand, like the 10 right there is just going to give us 10. And then so what do we want to do here? Well, we want to get the 11 out of it. And then so the thing about this is that every single path from like this tree is going to start with the roots and then go to one of the branches. And then so every single path is going to be 1 plus this path. No, in this case, it's the 1, or like whatever label that you have. It's going to be 1 plus whatever path that you have starting from like a certain branch. And to get the maximum path out of that, you're going to take the maximum path from out of all the branches. So in this case, note that the 10 came from this tree right here, and like 8 came from right there. So if we decide to go down on the left side, then the maximum path that we can get from this tree is going to be 8. And you can imagine our total sum is going to be 1 plus 8 equals 9. So the maximum sum, if we decide to go down the left path, is going to be 9. And maybe we could do better than that. But on the other hand, if we decide to go down to the right side, max path sum of that branch returned is 10. So if we add together like this 1 and the 10, then we get 11. That's the path, that's the maximum sum that I can get while taking the path to the right branch. And so we want the highest one, so we're going to take that 11. And that's how we're going to go about solving this problem. So make a recursive call on each of the branches, and then essentially get the maximum path, like maximum value out of all the branches, like of the 8 and the 10. We're going to get the 10 out of it. And we want to add like whatever we had earlier, so our current label. So like imagine, let's make this a 2 actually. We're going to take that 10, we're going to add 2 to it, and we're going to get 12. And that's going to be our final answer. So picking the branch that has the maximum sum, and that should be, and adding our current label to it, that should be like the maximum sum of the paths, the maximum path sum. And so let's get started with our code. And so starting off, you're gonna always like decide to do this if you want, but if we want a nice base case, for example, we could say if is least of t. So if you always have like an open coding problem and you could just like code whatever you want, isLeaf is always going to be a great option to do. And so if it's a leaf, then what do we want? Well, if we had the example writing down here, if we had the example of like the leaf 4, the maximum path sum, there's only one way you could go, and like you can't go into any branches. And so the maximum sum of this tree is going to be 4. And so in this case, it would be the label of the tree. So we're going to return label of t right there. And so that's our base case. And now the question is, how do we handle our recursive calls? And so the same principle applies. We can like code it up the same way as how we did the height problem. So we would have like a maximum value, and we would go through each of the branches and try to find this maximum value. And so I'm going to go ahead and take care of it here. And so we can start out with maybe like an empty list. So maybe like sums equals like an empty list. And we're going to go through this list of branches. So for b in branches of t. And what do I want to do? I want to call maximum path sum, and we want to remember that number. So what we're going to do is we're going to say sums.append of this recursive call to that branch. So max path sum of branch. You can imagine in our diagram right here, we would be calling that branch of like the 5, 1, 3 tree, and we would be getting 8 out of it, and we would add 8 to that sums list. And we're going to keep on doing it for every branch. And once we've done it for every branch, then we can take the maximum of that branch. So max of sums. So we got the maximum thing. In this case, it would be like the number 10. And what did we want to do to it? We wanted to add that label that we currently have. So that would be label of t plus max of sums. And we're going to return that label right there. And that should get us like the total, like the maximum path sum of that tree. And so, yeah. And so I guess one thing to note is that there is something that we did earlier that we can't do now. So here we had like a sums variable is equal to 0, and we took the maximum of like the sums and like the 1 plus the height. And so the thing to note about this is that I guess it could be true, but here we don't really assume that numbers are going to be like always positive. So if you imagine that you had like a -1, -1, -1, etc., we can't say that sums is equal to 0, because let's say like the best path was like that the sum of the path was like -3 or something. We can't like overwrite that with the 0 in this case, with the approach of like taking the like starting with 0, going through it and taking the max value. But one thing you can do is, here's an alternative approach for b in branches of t. We're gonna say sums equals flow of negative infinity. So when we say it's like flow of negative infinity, then what's gonna happen here is that any value of maximum path is definitely gonna overwrite this sums value right there. So we could say like sums equals the max of sums and max path sum of that branch, and then we can return label of t plus that max sums. And so these are two different approaches that you can take. Doesn't really matter which one you do, but all good. And yeah, let me see if there's actually what their solution is. Maybe there's like a list comprehension one. To be honest, I'm too tired to think right now, so I'm just gonna go over here. But yeah, let's see what they have to say. Max path sum. Okay, yeah, so so they do have 0. They do assume that they are all positive values, or like non-negative values, but yeah, so I guess you can ignore what I said, but in the case of like negative values, this wouldn't really work with like sums equals 0, but just keep that in mind. Yeah, and so I guess like another solution that they did was a list comprehension. So if it's a leaf, then we return label of t. And like another solution that we have here is essentially the same thing as this solution right here. We did the same thing in like this function height. And so you can take the maximum, apply like max path sum on each of the branches. That's list comprehension. And we're going to add the label at the very end. So same principle applies. But yeah, hope that made sense. Once again, if you have any questions, feel free to let me know. Hope you're all having a great Friday night and like doing something fun. But yeah, I will see you all sometime. How do I